So in the last video, we were talking about this example of pierced ears, and we made a two-way table to determine how many males you would expect to have pierced ears out of this class, and this is what we came up with. Well, another way to display our results is to use a Venn diagram, and these should be familiar to you. So what we can look at are how we're going to divide up our Venn diagram. So first of all, this is going to include our entire sample space. In our event A was that how many people were male. And so we said that 90 out of 178 are male. And so that would be included in this part right here. We'll call this A. And over here, event B was pierced ears. And we said that there were 103 people that had pierced ears. So over here in the blue area would be B. Now, the overlapping area is outcomes that are both P of A plus P of B together. Or we could call that P of A and B. So if you took whatever you had from A, whatever you had from B, added them together, it's that overlap. It's going to be counted twice. And so what we can notice is that number is 19. So then, to figure out how many are in event A, you would subtract out the 19 from 90, or you can just look at the table, and you can see that it's 71. And event B, we're going to have to subtract out that 19 that overlaps, and we can see that that's going to be 84 from the table. And so the overlap of P and B is 19, but if we wanted to know the total in event A and event B, we would add all those numbers up, and that's where the 174 came from. Okay, let's look at some diagrams. At the bottom of your paper, you will notice that I have drawn what they look like for you. I'm just going to draw them freehand up here. So for example number 1, we're looking at the union. It's a set of all outcomes in either A or B. And so what that looks like, if you have a Venn diagram, and this is A and this is B, A or B looks like everything that's included in the two sample sets. An empty set is a set that has absolutely no elements at all. And so that would look like, okay, and then the intersection is the set that contains elements common to both. So that would be if you're looking at your sample set and you've got your your overlapping area here. That's your intersection. So disjoint means that they don't connect at all. So that looks like the drawing down there where the two circles are completely separate. They're mutually exclusive, or what we call disjoint. They don't have that overlap where you could be both. You have to choose one or the other. You can't choose both. It's kind of like that situation. All right, let's look at the general addition rule for two events. This is if you want event or B, you can take all of event A, which would include that overlap, and all of event B, and then you got to subtract the overlap part. So that's one way to find the probability of A or B. All right, let's try some examples. So we got a standard deck of playing cards. There's 52 cards. Each suit has 3 cards. So if you don't know, there's a spade. A spade has 13. A heart has 13. There's a club, and that has 13. And a diamond also has 13. So there's 52 total cards. So you want to make a two-way table that displays the sample space for this situation. And so we're looking at face cards. There's a total of 3 per suit. So that's 3 hearts, 3 clubs, and 3 diamonds for a total of 12. 3 face cards, 4 options, 3 times 4 is 12. And then we know that there are 13 cards that are hearts. And the other event, event B, is getting a heart. So let's make a two-way table for the sample space. The first outcome is event A, which is, let's say, face cards. And over here, we're going to talk about hearts. That's event B. And we're going to say yes or no, and yes or no are our options. And over here, we'll have our totals. So that's what it should look like. So what is the event that you could have a heart and a face card? Well, if we look over here at this diagram, 3 out of the times you're going to have a heart and a face card. So what's left with having just a heart but no face cards? Well, 13 minus 3 is 10. So that leaves a total of times that you can get hearts. All right, the next option we're going to look at is no hearts and yes to face cards. So if this leaves an option of 3, 6, 9, so 9 are going to be face cards that are not hearts, which leaves a total of 12, probability of 12 cards that will give you a face card, which is what we said the total should be. So now we've got to fill in the spaces. We know there are a total of 52 cards in a deck. So that leaves me with 40 that have to be here. So I can use some reverse mathematics, and I can see that no hearts, no face cards, that's going to have to be 30 cards, and 30 plus 9 is 39. So that's my two-way table. Now I want to find the probability of A and B. And so the probability of A and B is that overlap, where the two come together. And so in the table, I can see that as being right here. The 3, they're both face and. Now if I wanted to see that in a Venn diagram, I could simply draw my Venn diagram. And the 3 would go here. And let's call it event A was face cards. So I'm just going to put an F here and an H here, just to remind us that that's face cards and that's hearts. So the number of cards that are face cards that are not hearts is 9. And the number of cards that are hearts but not face cards is 10. And so you should see that there. And then what you can actually do is what's not included in our events are these 30 cards right here. And so you can go ahead and write them outside the Venn diagram because that's where they are. Okay, so now the question is, why doesn't the probability of A or B equal the probability of A plus the probability of B? Well, if we look, what is the probability of A? Well, the probability of getting A is 9 plus 3, which is 12. And the probability of getting B, or hearts, is 10 plus 3, which is 13. And what you'll notice is you get 25. Because we counted the 3 twice. We counted it once for part A and once for part B. So that's why you have to use the general rule and then go back and you have to subtract the probability of A and B because you don't want to count it twice. So you would then subtract the 3 and you would get a total of 22. And if you notice, 9 plus 3 plus 10 equals 22. And so the probability of getting a heart or a face card is 22 times out of 52 cards in the deck. The probability of getting a heart and a face card, well, that's going to happen 3 times out of 52 cards in the deck. Okay, so let's look at another example. This one's called phone usage, and we're going to do this one together again. So it says, according to the National Center for the Health of Statistics, they found that 60% of U.S. households have a traditional line, and 89% of the cell phones have cell phones, and 51% had both. So I can tell from this problem that these are not mutually exclusive. So my Venn diagram is not going to look like this, because there's this keyword, both. So I know my Venn diagram is going to look something more like it. this, and this, okay? So the first thing I'm going to do, though, is make my two-way table. So my two events are landline, we'll call that P of A, and the other event is cell phone. That's event B. And the question is, do they or don't they? Yes or no? And over here again, yes or no. And I'm going to go ahead and draw here with some overlap so that I can have my totals. Okay. So let's go ahead and fill in what we know. We know that 51% had both. And so that's yes and yes. 51% goes here. And we know that there were a total of 60% had landline. So if you go down the landline column, this would be the yes landline column. All the way down here, that would be 60%. And over here, the cell phone column, this is the yes cell phone column. All the way over here is where 89% is going to go. And we know from our basic probability laws that this has to add up to 100%. And so for this table, we actually have to work backwards. So what's going to go here is 40%. And what's going to have to fill in here is 11%. Now let's work backwards. If this is 51%, you're right. This has to be 38. And if this is 51%, then to add up to 60, this has to be 9, and 9 plus 2 is 11%. So in filling in my Venn diagram, if I call landfills here event A, I'll label it L, and then I'm going to call cell phones over here event B. I'm going to call that C for cell phone. What lands in the middle is that 51%. Okay, and so these are the numbers we're looking at. 9, 51, and 38. And so 2 is going to be left on the outside. It's not going to be included. So then the question is, landfill, not cell phone, is 9. Cell phone, not landline, is 38. That's where I fall. We don't have a landline anymore. All right, so now we've constructed our Venn diagram. Now we want to find the probability that a household has at least one of the two types of phone. So that is the probability of the union of both A and B. You want both types of phone. So the probability of A plus the probability of B, but you're going to subtract out the probability of the intersection of A intersecting B. So the probability of A is 60. The probability of B is 89. And the probability of both is 51. So 60 plus 89 minus 51 is 98%. And you can also get that by adding 9 plus 51 plus 38, or just subtracting the 2 that doesn't include. All right, find the probability that a household has a cell phone only. Well, we've worked that out. 38% of the households have only a cell phone, not a landline. And 2, man, these people, I don't even know where those people are living. They have neither a cell phone nor a landline. Anyway. So it's a lot of math. It can be a little bit confusing, but I've got some more practice problems for you to work on. If you need help, let me know. These are attached in your packet. You are only responsible for these particular problems at this point. So good luck. If you need help or you want to work with a partner, do it. Please remember, all these notes are due by Friday.